Welcome to the DIY Honda Garage channel. The diagnostic trouble codes P2096 and P2097 pertain to the fuel trim system's performance after the catalytic converter in the Honda Pilot from 2016 to 2022. Specifically, P2096 indicates the system is too lean on bank 1, meaning there's an insufficient amount of fuel in the air-fuel mixture post-catalytic converter. Conversely, P2097 suggests the system is too rich, with an excess of fuel present in the same zone. It's crucial to understand that these codes point to potential issues with the performance of the vehicle's exhaust and fuel systems, specifically following the catalytic converter. These problems can affect engine performance, leading to decreased fuel efficiency and increased emissions. To effectively troubleshoot these codes, one must consider the potential related DTCs listed in the documentation, which could reveal underlying issues that need to be addressed first before focusing on the P2096 and P2097 codes. The DTCs P2096 and P2097 directly reference the post-catalytic converter fuel trim system, which is critical in managing the efficiency of the engine's exhaust systems. Bank 1 refers to the side of the engine that contains cylinder 1, usually the front bank in a V-type engine layout. Key components affected include the rear air-fuel AF sensor, which provides vital feedback regarding the air-fuel mixture after it exits the catalytic converter, and the rear secondary heated oxygen sensor, HO2S, that further monitors this mixture. These sensors are strategically located in the exhaust pathway, primarily between the catalytic converter and the exhaust pipe, and their functioning is crucial to ensure optimal engine performance and emissions control. Problems within these components can lead to improper fuel trim adjustments, resulting in either a lean or rich running condition, which these codes aim to identify. Several factors could contribute to the activation of DTC P2096 and P2097. Firstly, poor connections or loose terminals at the rear AF sensor and rear secondary HO2S can disrupt the communication vital for the PCM's operation. The PCM, or Powertrain Control Module, is responsible for regulating various engine functions and adjusting fuel delivery, so compromised sensor signals can trigger these DTCs. Additionally, leaks in the exhaust system between the sensors can lead to incorrect readings of the exhaust gases, making the system misinterpret the air-fuel mixture's quality. Blockages or restrictions in the exhaust could also lead to abnormal pressure or gas flow, further complicating the signals sent to the PCM. Faulty sensors themselves, whether it be the AF sensor or the HO2S, might not accurately record the conditions necessary for effective fuel trim adjustments. Lastly, issues with the PCM itself can cause erratic behavior that leads to erroneous DTC activation. When dealing with codes P2096 and P2097, a few symptoms are typically evident. A significant decrease in fuel efficiency is one of the primary indicators, as improper fuel trim settings can lead to unoptimized fuel usage. If the engine runs either too lean or too rich, it could significantly diminish gas mileage, directly impacting the driver's wallet. Increased emissions are another preventative, as the vehicle may fail emissions testing due to its inability to meet required environmental standards caused by malfunctioning fuel trim adjustments. Engine performance issues can also arise, such as hesitations, stalling, or diminished power, as these codes suggest that the air-fuel mixture is not being properly managed. These conditions can create an unsatisfactory driving experience and potentially lead to further engine damage if left untreated. The first step in troubleshooting DTC's P2096 and P2097 involves verifying the nature of the problem. Begin by placing the vehicle in on mode, but do not start the engine yet. After this, use the HDS or Honda Diagnostic system to clear any existing diagnostic trouble codes from the system. This step ensures that you're starting fresh, allowing for an analysis of the current operating conditions of the vehicle without the influence of old codes that could affect diagnostics. Following this, proceed to start the engine and hold the speed at 3,000 RPM while it remains in either park or neutral until the radiator fan activates, which signifies that the engine has reached a certain operational temperature. After this initial run, the next critical action is to let the engine idle, setting the stage for further evaluations of the engine's performance and related DTCs under specific driving conditions. The second step delves into the cylinder air-fuel, A-fuel variation check to ensure that the A-fuel ratios within the cylinders are operating within acceptable limits. Begin by starting the engine again and holding the engine speed at 3,000 RPM without any load while ensuring the air conditioning, AC, and all other electrical loads are turned off. This testing environment allows you to assess the engine's A-fuel mixture without any confounding variables affecting its performance. Utilize the HDS to conduct the cylinder A-fuel test, which examines how well the A-fuel mixture is regulated in real time. It is crucial to perform this test 3 separate times to gather precise measurements and ensure consistency in the readings. If this evaluation produces satisfactory results, it indicates that the A-fuel system is functioning correctly, allowing you to progress to the next troubleshooting step. If not, this necessitates a closer inspection for any related issues, specifically those outlined by an additional DTC P219A. In the third step, you will conduct an inspection of the exhaust system to identify possible leaks, clogs, or restrictions that may affect the air-fuel mixing process post-catalytic converter. To initiate this check, turn the vehicle off and examine the exhaust system for any visible signs of damage or wear. Areas between the rear A-fuel sensor and the secondary HO2S should be inspected meticulously, as leaks in this section can lead to incorrect readings that would trigger the DTCs. Any noted leaks or blockage needs to be repaired immediately, as they could hinder the proper operation of the engine and cause incorrect readings within the fuel management system. If no issues are found during this inspection, you can confidently move on to the next troubleshooting step for further diagnostics. The fourth troubleshooting step involves checking the rear AF sensor by substitution, allowing for an assessment of whether the sensor itself is the root cause of the issues being faced. Begin by replacing the suspect rear AF sensor with a known good unit to ensure you are working with a verified component. Following this, reconnect all connectors to ensure there are no loose or improper connections that could affect data transmission. It is also essential to reset the PCM or powertrain control module using the HDS, facilitating a fresh start for the module in terms of learning the new sensor characteristics. Conduct the PCM idle learn procedure afterward to help the PCM recalibrate and reconcile its operation with the newly installed sensor. As the engine runs at 3,000 RPM without any load, monitor conditions, including engine coolant temperature and vehicle speed, to assess the system's performance, concluding this step by observing the HDS for the statuses of the DTCs P2096 and P2097. After conducting the necessary repairs and substitutions in accordance to the previous steps, the final verification step ensures everything is functioning as intended. Use the HDS to monitor the results to ascertain whether the DTCs P2096 and P2097 have been cleared and if the system is showing a passed status. If the readings indicate success, it is time to replace the original rear AF sensor if it has not already been done. Implementing preventive maintenance measures can significantly contribute to preventing future occurrences of DTCs P2096 and P2097. Regular inspections of the exhaust system should be part of routine vehicle maintenance, ensuring no leaks or blockages can develop over time, which could lead to erroneous sensor readings or fuel trim issues. Additionally, maintaining clean and secure connections at the AF sensor and HO2S will ensure consistent performance and reliable data transfer to the PCM. Lastly, using high-quality fuel can minimize carbon buildup within the system and enhance the longevity of sensors, thereby maintaining appropriate engine performance. Such practices not only help prevent the emergence of diagnostic trouble codes, but also optimize fuel efficiency and reduce emissions for the Honda Pilot, leading to a better overall ownership experience. In conclusion, effectively diagnosing and addressing DTCs P2096 and P2097 is pivotal for maintaining the Honda Pilot's operational integrity from 2016 to 2022. Understanding the significance of proper fuel trim management post-catalytic converter is crucial, as it heavily influences engine performance, fuel efficiency, and emissions control. Monitoring associated sensors and ensuring the exhaust system is in good condition are fundamental practices that can not only minimize unnecessary DTC triggers, but also lead to long-term cost savings for the vehicle owner. Promptly addressing repairs as soon as these DTCs arise will enhance overall vehicle performance and compliance with environmental standards. By adopting these troubleshooting techniques and preventive measures, Honda Pilot owners can ensure they navigate their driving experience with confidence and reliability. Please like and subscribe to the channel. See you next time!